I can start now, right? Okay, cool. Um, Hello everyone. Thanks for coming. And today I'll be talking about streaming Postgres CDC into Iceberg without blowing things up. And my name is Yingjun Wu, and I didn't really bring any promotion code. But definitely we have the Slack committee and after link after this talk. So I'm the founder of Writing Wave Labs. Actually, before starting a company, I worked for AWS. But it's essentially my first time to come to this office because I was based in Palo Alto. Yeah. And before joining Redshift, I was at IBM Research Armadan, and I've been working on stream processing at the database system for probably over a decade. So something about Writing Wave. Writing Wave is actually a distributed SQL streaming database. And I think Victor did a really very amazing talk about what streaming SQL is, right? What a streaming database is. And the Writing Wave started from a streaming database. And essentially, nowadays we actually do more than just stream processing. We started from stream processing, but nowadays we actually do something like streaming ingestion, stream processing, streaming analytics, stream management, right? Or even storing their data in Iceberg. But today I'll definitely not talk too much about how we do stream processing, right? And how we query Kafka. My focus will be on Iceberg because definitely everyone is super interested in Iceberg. So before starting about the talk about the Iceberg, let's just review the two acquisitions, right? Happened last month. Databricks just acquired a company called Neon, which is a serverless Postgres company, right? And at the same time, Snowflake acquired another company called Crunchy Data, which I'm not sure whether Crunchy Data is New York based, but definitely they are also doing Postgres, and they have been doing Postgres for over 10 years. So what's a pattern? Definitely the first pattern is that Databricks definitely hate Snowflake, and they basically hate each other, right? But at the same time, we also find that they actually have common interest. What's a common interest? The common interest is that both of them love Postgres, and they also love Iceberg. So the thing here that we have the operational data stored in our Postgres, and because we definitely do not really want to store all entire data lake in Postgres, right? That's not quite possible. Then where to store it? Yeah, for sure. Iceberg is definitely a perfect location, right? Perfect place, right? You do not really need to worry about the vendor login, and the only thing you need to do is to bring your own S3 bucket, and you can store everything in S3 bucket in an open table format. That's great. Right? So Postgres is for operational data, while Iceberg is for analytical data. Then how do we connect these two things? Definitely, we need to send the data from Postgres to Iceberg, right? Well, there's no magic, right? Well, you have to build some ELT or ETL pipeline. So in the past, we probably have to have a ETL pipeline, but actually over the last 10 years, I definitely know that a lot of people are promoting for ELT pipeline. But realistically, we found that totally depends on your use case, right? So whether you really want to have just to do something like a data replication, or you want to do some transformation, right? No matter whether you want to do data ETL or ELT pipeline, you definitely want to have a system to continuously ingest the data from Postgres CDC, optionally you can do processing, and then send the data into Iceberg. It sounds pretty simple, right? And what kind of system we can use to do such kind of work, right? Probably people will say, okay, 5chan, right? But I have to say that 5chan is definitely a great system, right? But it's not that streaming. Yeah, definitely they have the streaming mode. But it's more for the application side, right? Basically ingesting data from your Salesforce, or probably ingesting data from your HubSpot into, let's say, Snowflake, or into Redshift, into BigQuery, right? But today I'm more focused on data engineering things, right? We want to focus on what our data engineers really love, right? Our data engineers love Debizium, love Writing Wave, love Kafka, love Flink, right? Well, what's a division? I think Victor also mentioned that. Well, basically, it's basically a specialized tool for ingesting data from all kinds of the CDC, right? Well, from let's say MongoDB CDC, from Postgres CDC, from MySQL CDC, from probably SQL Server CDC, or probably even from Oracle CDC, right? Division is such a great tool, and can we just use Division for everything? Yeah, probably yes. But at the same time, I can mention something more about the division later. But definitely at the same time, we also have some other systems that can do the exactly the same work to ingest the data from your Postgres CDC and send the data into Iceberg. The three systems we have is Rising Wave, Kafka, and Flink. And what's a common thing? I mean, the common thing is I don't really think that's where they hate each other, but the common thing is they are all based in Division. So Kafka as well. Like Kafka Connect is definitely based on Division server, and for Flink, well, they actually hacked the Division code. I think I believe that's where they hacked the Division code. I didn't really check how heavy they really have the code, but for Rising Wave, we actually use Division embedded server. So that's very interesting, right? For three different services, three different systems all use Division, but use Division in different ways, right? So Division is definitely, that means that your Division is definitely an awesome product, right? So again, well, I mean, I'm not trying to tell you, okay, which system you should use, right? Well, I mean, you probably can just use Division, or you probably can use either Rising Wave or Kafka or Flink to ingest the Postgres CDC to a CDC from Postgres and send the data into Iceberg. But what you really need to care about when you do such kind of thing, right? When you build such kind of ELT and ETL pipeline, I can tell you that's it's not just about connecting a Division to Postgres. There are a lot of things you probably have to worry about, and you probably need to have to worry about at least the 5 items. The first thing is about failure handling, right? In many cases, people will imagine that, okay, look, I connect my Division to Postgres and then it's done, right? But the most challenging thing we found that you could not rely on your upstream systems, right? Well, upstream systems can fail, right? Postgres can fail for all kinds of reasons. Probably because it's wrong on memory, or probably because some, let's say, you got attacked, right? Well, DDoS attacked, right? For all kinds of reasons, your Postgres can crash, or probably restart, or probably the network is not stable, right? AWS is down, right? So it's everything is possible, right? So the thing you probably need to first worry about is that whether you can resume the from the failure, and make sure that the recovery is the pipeline is so-called resumable. Resumable means that you can actually, even if the Postgres crashed, you can recover the pipeline from the exactly same location, right? It's from the exactly same offset. So how do we do that? Modern technology, I can tell you that all the 3 systems I mentioned can achieve that by helping you to reserve the correct LSN, and LSN means log sequence date number, right? Correct me if I got it wrong, and can preserve the LSM and recover from the correct position location if the node failed. And second thing, definitely upstream services can fail, but at the same time, downstream systems can also fail, right? I know that for Postgres, Snowflake, not Snowflake, Iceberg store data in S3, and the S3 is definitely reliable, but I have to tell you that there are probably network outages, right? So you're probably paying your, let's say, Polaris or probably to your catalog service, and there's no response, right? So everything is possible. And if this happens, then what it means? Any issues with that? The issue here that you probably will have to if your system continues to send the data into downstream systems, you will find that it will be the system will crash because it will run out of memory. So how do we do that? You have to buffer your data correctly. to ensure that even if the network outage occurred or downstream system failed, you can recover. You can continue to send the data into downstream systems once the downstream services get recovered. So that's the first thing, right? So what kind of system can do that? Well, I mean, RisingWave can do that, Kafka can do that, and Flink can do that. Everyone can do that. And second thing I want to mention, pinpoint I want to mention is about the backfilling. And the backfilling is typically it's not like mentioned by many people because people say that's why I only care about my runtime, right? But essentially, one of the key challenges in doing the CDC, CDC is that interesting from the CDC is that how do you initiate the processing, right? And this technology called the backfilling. Basically, you need to reload the entire database, upstream database, and image of the entire upstream database and send the image to the downstream system. The challenge with Debian is that Debian during the backfilling phase, Debian will actually put an access shared log on your database table, on your upstream database. What it means, I mean, upstreams you can still query your database, and you can probably still write it into your database, but you could not operate your database. Let's say you could not do, let's say, alter table on your database if there's an access shared log. So in some cases, actually Debian can spend, let's say, probably 7 days to backfill a table. It means that during these 7 days, you can do nothing. You can probably have to you probably have to wait. So what's the solution here? Actually, the solution here that's we actually have to implement the lock-free snapshotting mechanism to ensure that we actually do not need to hold the access shared log during the backfilling. And which system can implement that? Well, I mean, Flink and RisingWave can do that nowadays. And the second thing here that's regarding backfilling is that you actually also have to do the parallel snapshotting, which means that instead of using one single thread to reload the entire Postgres image, you actually have to chop up the database into multiple chunks, smaller chunks, and reload the smaller chunks in parallel in order to parallelize the backfilling phase. And again, in today's market, I believe that both RisingWave and Flink can do that. And third challenge, well, I mean, it's probably not a big challenge, but I mean, you definitely want to support all kinds of data types, right? Everyone talk about GenAI, and GenAI means that you actually have to store your data in, let's say, probably your image data, probably your JSON data, probably your video data, right? And in Postgres, it's called toast columns. And you actually, when you ingest data from Postgres, you actually need to care about whether your CDC tool can support post column. And actually, I can tell you that for Debian, you actually have to, the default mode doesn't really support toast column, so you should be very careful. But the RisingWave instead will support for all kinds of other data types. And the fourth challenge regarding Iceberg is that Iceberg is unfortunately notoriously known for that's why it has a small file problem, which means that if you ingest a lot of small files into Iceberg, then your query performance can be super bad. So what we can do? Definitely people are saying, okay, let's just do group inserts, right? Well, we can just insert a bunch of updates, inserts, probably deletes into batches in the buffer, and then we probably flush those updates into my Iceberg let's say every single minute, or probably every single 5 minutes, right? It's great. It's great. But one thing I also want to mention is that that's actually not enough. Why that's not enough? Because you have no idea about how much data you can ingest within a minute, right? Probably within this minute, you probably get 1,000 events. But in next minute, you probably will ingest 1 million events, right? So small file can still happen, right? How do you do that? So as a data ingestion tool, we actually can do compaction, and that's how RisingWave is different from a lot of other systems. That is, RisingWave actually can do compaction for you, and even if you write your file into Iceberg, we can actually still do the compaction for you, and in order to merge the small files into larger files, so as to optimize the storage. How do we implement that? we actually adopted data fusion, right? I think where's the Andrew? Yeah. Okay, cool. Yeah. So yeah, we adopted data fusion, and it's definitely great. And we are currently working with some other companies who are like Cloudflare, working on a project called Iceberg Compact, which actually applies data fusion into the Iceberg compaction services. That's great too. So yeah, check out this project and check out RightWave. And RightWave has already put this project into production. And last thing I want to mention, give me one moment, okay? Last thing I want to mention is about cost. So I have to tell you that essentially for a CDC ingestion, for data ingestion, you spend the most of money not in CPU, not in storage, but in network. So when you choose a CDC tool, you actually need to care about whether you are using let's say a public the deployment mode, because if you use a cloud-based fully managed cloud service, you probably will be charged for the networks, right? You will probably notice that some vendors like say 5chan, right, will probably charge you by number of rows. It's not because they are greedy, they are probably yes, but it's mainly because they actually have to pay for AWS for the network fee. So how to solve this problem? You probably can consider, let's say, using some so-called BUOC deployment mode, which means that you can deploy your data plan in your own VPC in order to avoid paying AWS for the network fee, right? So it's a loss for the AWS, but it's definitely very, very beneficial for the customers, right? So yeah, to summarize, your checklist for moving data from Postgres to Iceberg: failure handling, backfilling, for data type support, more files, and the cost. So yeah, that's all my talk. And if you are interested, I do not really have a promotion code, but you can join our Slack community, writingwave.com. Yeah.